All right, so for this video, I'm still on lesson 3, but we're going to be looking at synthetic division. And this time, with synthetic division, it's a completely different way than long division, but you will get the same answer. All right, I'm on page 14, so I'm going to do some examples with you. And I do want to kind of preface this by saying that synthetic division works when you have something like x minus 1, x plus 4, x minus 8, things like that. If this was a 2x minus 1, then it's a little bit trickier, and sometimes it would not work. Okay, so like if I was dividing by x squared plus 1 or something, then this synthetic division would not work, and I would have to do long division. So that's why long division is so important. I think once you see synthetic, you'll probably like it better, but again, it doesn't always work. Okay, so that's where long division comes in, but synthetic is definitely pretty user-friendly. All right, so with synthetic division, you're going to start off with an L. All right, now the top of the L, you put all of the terms from here. All right, so that's a 1, a -4, and a +3. Give yourself some space so that you don't start messing things up, okay? It starts getting kind of crammed together. Notice that I didn't put any variables. It's only the numerical part, okay? Also, pay attention to signs. This is a -4, so that stays with it. All right, now on the outside of the L, you put the root of whatever you're dividing by. So the root here would be +1. The reason why the root is +1 is because if I were to set that equal to 0 and solve for x, I would get +1. So for example, if I said x minus 1 equals 0, I'd have to add 1 to both sides, right? And I'd get 1. That's called a root. It's one of the solutions. So 1 goes outside of here. So if this is negative, this is positive. If this was positive, this would be negative, okay? So now we're going to get started. So this is the framework. Now to get started, this first term always drops down. All right? The very first term always drops down. Now you're going to multiply the outside. All right? So you multiply the outside. 1 times 1 is 1 to get the inside. So, and then you add down. So -4 plus 1 is -3. Now we multiply the outside. +1 times -3 is -3. And then we add down to get 0. All right. Now, whatever you get at the end, you box that off. That is your remainder. This is the remainder. Now, think about solutions or answers from right to left. You always kind of go backwards. So it's like the constant, the x squared, the x cubed, and so on. So this would be the constant. This would be the x. If I had more, it'd be the x squared, the x cubed, the x to the 4, and so on. So my answer, this is not my answer, this is my work. My answer is x minus 3. No remainder, so I can leave it just like that. All right, so let's look at another one. All right, so on this one, we're going to set up our L. At the top, we have a 2, a -5, a -3. And because this is a -3, if we were to set that equal to 0, remember my sign would ultimately change, right? So that would be a +3. Remember, if this was positive, this would have been negative. All right, so that's how we set up our framework. Also, I do want to say that if we did have missing terms, we would have to have fillers just like we did with long division. All right, but this first term would drop. All right, and now we're going to multiply the outsides, right? So we multiply, 3 times 2 is 6. We add down to get 1. We multiply the outside to get 3. We add down to get 0. You always have your remainder, then it's your constant, then it's your x squared, x cubed. We don't have those. So remember, this is not my answer, this is my work. So my answer would be 2x plus 1, and then no remainder. All right, another example. you'll notice that this has a missing term. So 0x squared. So be careful. All right. So we're going to set up our L. We're going to have a 1. We're missing a term, so a 0. So if it's missing, you put a 0, a -10, and a -24. Again, give yourself some space because you'll start running out of space. All right. So on the outside, if I set that equal to 0 and solved for x, I'd get +3. Now, unfortunately, these examples all had something minus, and a lot of them have -3, right? But that does not always happen. So just kind of know that, you know, when you get to some of the other solutions or some of the other problems, I mean, like when you get here, it would be a -4 outside of the L, okay? When you get here, it would be a +1 outside of the L. All right, but for this example, we have our startup, you know, we have our little skeleton. So remember, the first term always comes down no matter what it is. We multiply the outside. All right, so 3 times 1 is 3. Add down to get 3. 3 times 3 is 9. Add down to get -1. Be careful, watch your signs. 3 times -1 is -3. Add down to get -27. The last term, you box it off. That's your what? Remainder. And then it's your constant, your x squared. And if you had more, you'd keep going, but we don't. So my solution or my answer is 1x squared +3x minus 1 with a remainder of -27 over, well, what were we dividing by? X minus 3. And that is the answer. All right. One more example. All right. And in this example, we're also missing a term. So 430x squared, right? So 4, 3, 2, technically a 1, constant. So we're going to set up our L. The numbers at the top are 2, -5, 0, -7, -6. A +3 on the outside because it's the root. All right, so the first term drops. And then we're going to multiply the outside to get the inside. So 3 times 2 is 6. Add down to get 1. 3 times 1 is 3. Add down to get 3. 3 times 3 is 9. Add down to get 2. 3 times 2 is 6. Add down to get 0. Remember, the last number, that's the remainder. Then it's the constant, x squared, x cubed. If you had more, x to the 4, x to the 5, and so on. All right, so don't leave your answer like this. This is just your work. The answer is 2x cubed positive 1x squared positive 3x positive 2, and no remainder. If you were to put a 1 right here, that would be okay. I wouldn't count off for that, but the 1 is not necessary, so really this is the simplest form. All right, so that is synthetic division.